Okay, welcome back everybody. This is section 8.5 and today we're talking about the area of a circle formula. Well, here it is. It's a pretty popular formula. Area equals pi r squared. It's popular, it's common. You may have already known this formula. But of course in honors geometry, not only do we want to know the formulas, but we want to know where they come from, right? So we, today in this lesson, are going to derive the formula for area of a circle. And you can see the note here. It says, relate the area of a circle back to the area of one of the polygons we have studied. Right? So we're actually going to relate it back to maybe two different polygons that we've studied, which goes right along with what we did previously, where we were building off of the area of certain polygons that we knew to derive formulas of area of other polygons. So let's get at it here. All right, so we start with a circle, right? Our goal is to derive the area formula. Well, let's imagine taking that circle and folding it in half. So we end up with this. Now let's fold that in half. And we end up with this. And let's keep folding it in half as many times as we can. Right? So we get that. And if we fold it again, we get that. So what have we done? We folded the circle multiple times to the point that our shape becomes almost a triangle. Right? Now I say almost because of course this part of that is curved. But if you imagined us folding this circle again and again and again, right, theoretically, we could fold that circle enough times that this shape that has a little curved edge on it would become so small that that curved edge would become essentially straight, thus giving us a triangle. Right, so for our purposes, we folded 1, 2, 3, 4 times, and we have a shape that looks very much like a triangle. So let's assume that it is, right? So now, if we unfold that circle, right, we now have our circle that looks like this, right? It's a circle that's broken into a bunch of sort of triangles. Now, if we took a pair of scissors and we cut out all those triangles and we rearranged them, we could rearrange them like this. And if each of those little curved parts, right, were essentially straight, then we would have a parallelogram, right? Two pairs of parallel sides. And we know the area formula of a parallelogram is base times height. Now let's take a little closer look at this parallelogram. So I've enlarged it some, right? And let's think about what the base and the height of this parallelogram are in relation back to our circle. Now remember, we cut out our so-called triangles, and it looks like we have rearranged them, so we have as many on top as we do on the bottom. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. Now this is an important realization, because what this means is we have half of the circumference of the circle on top, and we have the other half of the circumference of the circle on the bottom. Now we know the circumference of a circle is 2 pi r. Well, half of that, if we divided it by 2, the 2's would cancel out and would be just pi r. So what that means is the base of this parallelogram is pi r, right? Now let's think about the height of the parallelogram. Well, the height of the parallelogram would go from the top and would be perpendicular to the bottom, right? Now, just looking at that, what do we have? We have the radius of the circle, right? And so we know that the height of the parallelogram is the radius of the circle. So taking the area formula of a parallelogram, the base times the height, and multiplying the base of pi r times the height of r, we end up with the area of a circle formula. Area equals pi r squared.